Hello everyone, welcome to the next session on Advanced ANSYS Workbench tutorials. In this session, we will analyze the Y-shaped pipe for its static structural analysis. We will start by double-clicking on Static Structural module. We'll first go to Engineering Data Sources, General Materials. Stainless steel is one of the material which I'm going to use. The other material which I'm going to use is CPVC. So I'll click on Engineering Data Sources again. Here I'll add the material CPVC. I'll give the density of the material which is 1650 kg per meter cube. Also I'll give the value of isotropic elasticity. Young's modulus is 3.1 gigapascal, so E9. And the value of Poisson's ratio is 0.386. If you want, you can give the value of tensile yield strength, which is 57 megapascal. So I'll change the units over here to megapascal, and this is 57. I'll go to project and update project. Next, I'll go to geometry and right click, import geometry, Y pipe. Next, I'll go to model and double click. I'll first go to geometry, solid, and change the material to stainless steel. I'll go to mesh and generate. I'll go to static structural, right click, insert, fix support. I'll choose face option over here. Apply. Next, I'm going to apply pressure. So I'll right click, insert, pressure at these faces. Apply. Magnitude is 1.52 megapascal. I'll go to solution, right click, insert, deformation total. I also want to see the strain equivalent and the stress equivalent. I can also see the stress tool, maximum shear stress, such that I can get the safety factor. I go to solution and solve. First, we'll go to total deformation. You can see here it is 3 mm maximum over here, and minimum is 0. Now, looking at this, you can judge that the pressure is more for this pipe. Although the material we have given is stainless steel, still the pressure is quite high. So I can just reduce this to 0.52 megapascal and solve once again. Now let's check the total deformation. It has reduced this 1.02 mm. You can animate and check this result. Minimum is 0 at this end. We'll see the equivalent elastic strain. It is 0.00155, which again you can animate and see. This is the maximum value. Minimum is 5.9988 into 10 raised to minus 5. Then we'll see the equivalent stress. It is 237.71 megapascal. You can animate and check this result. If you want, you can remove the wireframe. You can go to edges, no wireframe, contour, smooth contours. We'll see the safety factor. You can see here the pipe is still not safe. In certain zones it is blue, which means it is between 10 to 15. Rest of the cases it is showing this orangish color, which is from 0.7957 to 5. And also in certain cases it seems to be red, which means it is between 0 to 0.79, which means the pressure is still high for this sort of pipe. Now I will change the solid to CPVC. CPVC obviously cannot hold this value of pressure, so I will reduce this further to say 0.1 megapascal. I'll go to solution and solve. Let's see the total deformation. It is 11.57 mm. Again, a very high value, which means the pressure needs to be further reduced. So we are not reducing it. You can try on your own by reducing the values and checking for which value the pipe will be safer. Currently, I'll leave it to this itself. You can animate and check the result. We'll go to the equivalent strain. It is 0.017 maximum. Minimum is 0.00075. You can click on max and min, and you can see where it is maximum and where it is minimum. If you want, you can also animate and check this result. If you don't want to see the max min, just click on them once again. Then we'll go to equivalent stress, which is 44.51 megapascal. So you can animate and check this result. This was the highest value. Minimum is 0.4705 megapascal. Last, we'll see the safety factor. You can see in certain zones it is showing blue color, which means between 10 to 15. Rest of the cases it is green, so it is between 5 to 10. In this zone where the bend is in this Y-shaped pipe, you can see it is between 1.1475 to 5 over here. And here again it is a little bit of blue, which is highly safe. So this gives you an idea that you can change the pressure value. It should be reduced or it can be increased based on this color. If you find it to be highly safe, you can increase the value of pressure. If you see that this is not safe, it is in the zone where it is showing minimum value, then you can reduce the pressure further. So that's how you can judge the pressure which this pipe can withstand. With this, I end the session. I hope you have understood the analysis. If you have any doubt, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.